Hi dear students, myself SANTOSH VJ. I welcome you for additive manufacturing class. Dear students, in my last classes we have discussed about powder metallurgy technology in module 3. Today we shall discuss about module 2 which is about hydraulic and pneumatic systems. Dear students, let me continue the session. Now we will look into the syllabus which involves in module 2, which are system drives and devices. In that, hydraulic and pneumatic motors and their features, electrical motors such as AC, DC and their features, and actuators. In that, electrical actuators such as solenoid actuators, relays, diodes, thyristors and tracks, hydraulic and pneumatic actuators, design of hydraulic and pneumatic circuits, piezoelectric actuators, shape memory, alloys. Just outline of this module 2, which begins from introduction to actuators and classification of actuators. Let us discuss the pneumatic actuators and their classifications. Dear students, the content which we will discuss about pneumatic actuators, which are involves in introduction to pneumatic actuators, working principle of pneumatic actuators, construction and working details, as well advantages and disadvantages of pneumatic actuators and applications of pneumatic systems. And secondly, we will discuss about the hydraulic actuators. Here also we will discuss the introduction to hydraulic actuators, working principle and construction of hydraulic actuators, as well applications and advantages and disadvantages of hydraulic actuators. And third one, electrical actuators. The students, similarly here also we will discuss the introduction about the electrical actuators, working principle of electrical actuators, construction details, as well applications and merits and demerits of electrical actuators. Let's move on. Yes, dear students, coming to the main objectives of this module, which are given below. Explain the main types of pneumatic actuators, explain the functions of a single acting cylinder, describe the main types of controlling a single acting cylinder, explain the difference between the direct control and indirect control of single acting cylinder, draw the required circuit diagrams for both the systems. Now look into the introduction to actuators. An actuator is something that actuates or moves something. An actuator is a device that converts an input energy into a motion or mechanical energy. Dear students, the device that converts an input energy into a motion or displacement or mechanical energy. So this is called as a actuator. The input energy of actuator can be a manual, for example levers and shocks, or can be a hydraulic or pneumatic, For example, pistons and valves can be a thermal, for example, bimetallic switches and levers, and can be electric, for example, motors and resonators. Dear students, actuators are a final element in control system. This actuators was discovered by Logan in 1969. Okay, dear students, continue the introduction to actuators. An actuator is that creates a motion in a straight line as contrasted with a circular motion of a conventional electric motor. A linear actuator are used in machine tools and industrial machinery, in a computer peripherals such as disk drives and printers, in valves and dampers, and in many other places where linear motion is required. The hydraulic and pneumatic cylinders inherently produce a linear motion. Many other mechanisms are used to provide a linear motion from a rotating motor. Okay, let's come to the classification of these actuators. These actuators are classified by pneumatic actuators, hydraulic actuators, and electrical actuators. The pneumatic actuators are performed by a hydraulic or a pressurized air or gas. The hydraulic actuators are the main uh, media is used to run the hydraulic systems. Oil or water is used to run the hydraulic systems. In electrical, actuators are run by using electrical current or voltage. Let's coming to the pneumatic actuators, dear students, which are performed by compressed air or gas. As you can see the image on the slide, dear students, which is a prototype component uh, made by the hydraulic actuators, or this will be a hydraulic actuator for particular application. Let us discuss something about hydraulic actuators. A set of devices into it, one or more pneumo engines, which are determined to start the mechanisms or some other objects by means of pressured working gas, is called as a pneumatic actuator or pneumo actuator. Okay, dear students, the device is intended for transmission of potential and kinetic energy of the stream of compressed gas in the mechanical energy of the output link that can be, for example, a rod of the piston, a shaft of the turbine, or the case of the jet device is called as a pneumatic engines of the automated actuator. They are devices providing the power and motion to automated systems, machines, and processes. Dear students, a pneumatic cylinder is a simple, low cost, easy to install the device that is ideal for producing the powerful linear movement. And now coming to the basic construction of a pneumatic system. Dear students, as we can see, the image is a basic construction of pneumatic system, which are the many of the parts are indicated by the numbers. Number 1 indicated that this portion is indicated by number 1, which is called as a cushion seal. This portion is a cushion seal, And this portion, as you can see, that number 2, this area is a magnet, and this portion, what you can see, the number 3, this is the cushion sleeve, and this portion, as we can see in this portion, which is indicated by number 4, that is called a barrel. And what we can see, this portion, which is indicated by number 5, is a guide bush, which is, this is a portion is guide bush. As we can see, this portion, this is in green color, this is which is indicated by number 6, which is called as rod and wiper seal. So as we can see, this portion, which is indicated by number 7, that portion is called as, dear students, front end covers. And what we can see, this is a port, which is indicated by number 8, that is front port, dear students, which is called as front port. As you can see, this portion, dear students, which is indicated by number 9, that is called lead switch. And as we can see, this portion is a piston rod, dear students. This portion is a piston rod, which is indicated by number 10. And number 11, as we can see, this portion in between the 2 green lines, this middle portion is called as wear ring. And what we can see, the a green line at left side, dear students, that green line which is indicated by number 12, that is called a piston seal. What we can see, this portion, dear students, this below portion, which is indicated by number 13, this is the rear end cover of the cylinder. What we can see, this inside portion, which is indicated by number 14, that is a cushion screw. Hope you understand the basic construction of pneumatic system, dear students. Let's move on to types of pneumatic actuators, dear students. Pneumatic actuators are made in a wide variety of sizes, shapes, styles, and types, including the following: a single acting with without spring return, double acting, rodless actuators, rotary actuators, clamping actuators, and bellows actuators. Yes, dear students, as we can see the image on the slide, dear students, above line, which is indicated a single acting spring return actuator in one direction, which is called as a normally in, which means the pressurized or compressed air is inside the cylinder. That what we can observe in a schematic diagram, as this is the schematic diagram of the single acting cylinder. The compressed air is get entered into the cylinder. As we can see the below image, dear students, this is also a single acting spring return cylinder here, which is indicated that through the schematic diagram, the air is entered compressed air is exit or come out of the other ports, that is a rod end port. Hope you understand, dear students. A hydraulic cylinder is consists of a cylinder barrel inside which a tight fitting piston can move to and fro motion. The piston rod comes out of the cylinder, which can be attached to the component to which the motion is to be transmitted. Hope you understand. This portion is connecting rod. The pressurized fluid is supplied from the pump through the control valves. These are the control valves. This is indicated. As we can see, these are the control valves. It can enter into the cylinder through the through a port provided at the piston end of the cylinder. So as you can see, the piston end of the piston has two ends. This is the port 1 and this is port 2. In case of single acting cylinder, there is no port provided as the rod end side of the cylinder. Hope you understand. In case of single acting cylinder, the rod end, this side rod end of the cylinder, there is no port provided at the rod end of the cylinder. But when air under pressure enters the cylinder through the inlet port, as you can see, this is the inlet port, it pushes the piston forward. Yes, it pushes the piston in forward direction. The rod end of the cylinder has a return spring when the oil enters the piston end of the cylinder. Here the oil is enters the piston end of the cylinder. The piston is pushed against the spring force. This is the spring force. After reaching the forwardmost position, when the inlet port is connected to the tank, yes, this port is connected to the tank, the piston returns. The return motion is due to a return spring. The oil moves out of the cylinder through the same port of the. Dear students, now coming to the double acting cylinder. The double acting cylinder which compress the air to forward both outstroke and instroke. The superior speed control is possible. Non-cushioned cylinders are suitable for full stroke working at slow speed. Higher speeds with external cushions. Dear students, as we can see the left image, dear students, this is a 3D image of double acting cylinder. This is the schematic diagram of double acting cylinder. It has a two ports. Port A, dear students, as you can see, this is the port A at the piston end and port B at the rod end. Dear students, this is at the rod end, this is at the piston end. For the forward motion of the piston, the pressurized gas entered through port A and pushes the piston forward. The gas from the rod end port goes out of the cylinder through the port B to the tank. For return motion, the gas enters to the port B and pushes the piston a backward direction. Oil from the piston end now moves out through the port A back to the tank. So this is called a double acting cylinder. Does not require the secondary sources to push the piston inside the cylinder. Is a self-operated system. Hope you understand. Now coming to the advantages of pneumatic actuators. Simplicity of realization relatively to small back and forth motions. Sophisticated transfer mechanisms are not required. Low cost, high speed of moving is at reversion moments, tolerance to overloads up to a full stop, high reliability of work, explosion and fire safety, ecological purity, ability to accumulation and transportation. Dear students, there are disadvantages of pneumatic actuators, which are a compressibility of the air, incompressibility to receive the uniform and constant speed of the working body's movement, difficulties in performance at slow speed, limited conditions, use of compressed air is beneficial up to the definite values of pressure. A compressed air requires a good preparation, and here we can discuss some pneumatic applications. Some industrial applications employing the pneumatics are listed below. General methods of material handling: clamping, shifting, positioning, orienting, and branching of material flow. And general applications of packing purposes: filling, metering, looking, driving of excess, door, chute control, transfer of materials, turning and door or chute control, transfer of materials, turning and uh, inverting of parts, sorting of parts, stacking of components, and stamping and embossing of components. Let us discuss the hydraulic actuators. Dear students, as we can see, the image is a kind of hydraulic system application. Let us discuss the introduction of hydraulic system. A hydraulic drive system is a drive or a transmission system that uses the pressurized hydraulic fluid to drive the hydraulic machinery. The term hydraulic actuator refers to a device controlled by a hydraulic pump. The familiar example of manually operated hydraulic actuator is a hydraulic car choke. Typically, the principle used in hydraulic actuator system is that the working principle of hydraulic actuator is a Pascal's law. Dear students, you know the principle of Pascal's law. The pressure applied to a confined fluid at any point is transmitted undiminished and equally throughout the fluid in all directions and acts upon every part of the confined vessel at right angles to its interior surface. The mathematical expressions of Pascal's law, which is amplification of forces, since the pressure P applied on an area A gives a rise to a force F given as F is equal to P into A. Thus, if a force is applied over a small area to cause a pressure P in a confined fluid, the force generated on a larger area can be made many times larger than applied force that created the pressure. The principle is used in various hydraulic devices to such a hydraulic pressure to generate very high forces. The construction of hydraulic actuators. A hydraulic actuator system consists of three parts. Number one, a generator, for example, a hydraulic pumps driven by an electric motor. Second one is a combustion engine or a windmill, such as valves, filters, pipings, and etc. The third one is an motor, for example, hydraulic motor and hydraulic cylinders to drive the machinery. Dear students, let us discuss the hydraulic actuator parts. The parts of a cylinder, parts of a typical cylinder. Dear students, as we can see, the image is a construction of hydraulic cylinder attached to a machine parts. This is a ram attached to a machine member. As we can see, this portion is a port B, as we can call it a port B. As we can see, the bottom portion or area is called as a head, and this portion, as we can call, is an barrel. And as we can see, this is the portion is a top portion. As we can see, this is the sealed chamber, and this is the piston head, which is also called as a piston and rod assembly. As we can see, this is the port A at the piston end, and as we can see, this is the cylinder cap. Yes, let us discuss the working of hydraulic actuators. And hydraulic actuators are hydraulic cylinders typically involved in a hollow cylinder having a piston inserted in it. An unbalanced pressure applied to the piston provides a force that can move an external object. Since liquids are nearly incompressible, a hydraulic cylinder can provide the controlled, precise linear displacement of the piston. The displacement is only along the axis of the piston. The piston forms sealed variable volume chambers in the cylinder. The system fluid force into the chambers drives the piston and rod assembly. The linear movement is produced. Okay, dear students, let us discuss the classification of hydraulic actuators. The cylinders are typically classified by operating principles or by a construction type. Number one is a single acting or double acting cylinders, and tie rod cylinders, mill type of cylinders, and threaded end type of cylinders, or a one piece cylinder. The single acting cylinders exerts the force either an extension or retraction. They require an outside forces to complete the second motion. The double acting cylinders generates the force during the both extension and retraction. The directional control valve alternately directs the fluids to opposite side of the piston. The force output varies between the extension and retraction. Now let us discuss the hydraulic actuators. The two types of hydraulic actuators, one is a single and double acting cylinders. Dear students, as we can see, the left side image is indicated that a single acting cylinder. As we can see, the right side image is indicate the double acting cylinder. The working principle of these two actuators are just similar to the pneumatic actuators. The working principle is the same both of the actuating systems. Now, as we can see, the image is indicated that the hydraulic application of hydraulic actuators, tie rod cylinder. This is a particular application of tie rod cylinder. Let us see the one more example of application of hydraulic actuators. This is a mill cylinder. As you can see here, this is the mill cylinder actuators which we can use in industrial applications. Coming to the third image is indicated that threaded end cylinders, which is also another kind of application for the hydraulic actuator. Now the advantages of hydraulic actuators, let us discuss. Infinitely variable control of gear ratio in a wide range and an opportunity to create the big reduction ratio. The small specific weight, that is the weight of a hydro actuator, is in a ratio to transmitted capacity around about 2 to 3 kg per weight per kilowatt. The opportunity of a simple and reliable protection of the engine from overloads, a small sluggishness of the rotating parts, providing a fast change of operating modes, and the simplicity of transmission and rotary movement into the reciprocating one. The opportunity of positioning a hydraulic engine on removal from an energy source and freedom in making the configuration. And let us discuss the disadvantages of hydraulic actuators. Efficiency of an volumetric hydraulic actuator is a little bit lower than efficiency of mechanical and electrical transfers, and during the regulation it is reduced. The conditions of operation of an hydraulic actuator influence its characteristics, which is mainly a temperature is influence its characteristics. The efficiency of an hydraulic actuator is a little reduced in the process of exhaustion of its resources, owing to the increase in backslash and the increases of outflow of the fluid of volumetric efficiency. The sensitivity to pollution of working liquid and necessity of a high culture services. Just dear students, look at the images. These are the applications of hydraulic actuators, different applications which we can use the hydraulic systems or hydraulic actuators for different applications. Let us discuss the difference between the pneumatic system and hydraulic systems. As we can see, the a column in left side column, it is a pneumatic systems. In case of pneumatic power systems, the density of gas and air is lower than the hydraulic oil. The compressed gas is easily transmitted. In case of hydraulic power system, the hydraulic oil is not able to transmit easily. In case of pneumatic power system, the simple is very simple construction is very simple. In case of hydraulic system, the robust construction. In hydraulic system, the system is does not require special attention. In pneumatic system, does not require a special attention. In hydraulic system, power system requires the special attention to protect them against the rust, corrosion, and dust. In pneumatic system, the weight of pneumatic system is less as compared to the hydraulic power system. The weight is more than the pneumatic system in case of hydraulic system. The power to size ratio of pneumatic system is small as compared to the power to size ratio is more in hydraulic system. The pneumatic power systems do not present a fire hazard because of fire proof characteristics. In case of hydraulic power system, the hydraulic power systems present a fire hazardous due to a high oil pressure. The leakage problems does not affect the operation of pneumatic system. In case of hydraulic system, the leakage problem affects the operation of hydraulic power system. The last one is the contamination control is not required in the pneumatic system, but contamination control is required in the hydraulic system. Okay, dear students, now I will stop the session. We will continue to the left out topics in the next session. I hope you that this session was useful. Thank you.